Yeah, every lab needs a lab form. And like I explained why, right? So I can give those labs back at the end of the term. Let me get this first. So here's our PLC. What's one of the first things I need to do to connect to this guy? What's the next thing I need to do? Y'all hear Mr. Caffey, right?
Well, ours wasn't connected. You gotta figure out what's going on.
So what I need to probably do next? Yeah, we could. Right now we're okay, but what we need to do almost first on this one is make sure we have a link to the PLC. So Allen Bradley uses an application called RS Links, and it comes when you install the application on your computer. I'm not using the Ethernet this time, so notice when it should come up with an X down here. But this is what I'm using. I'm using the DH485. Sorry. I get to do that too. I don't. So first of all, we'd make sure we had the driver installed that supported the interface that we're using, right? That would be one of the first things we do. Now, once you've connected to the PLC, like down in the lab, you don't have to do this anymore because it already knows it's there, right? But if we was going to install a new PLC, the first thing I would need to do is make sure I had the driver installed. And what's the driver? I don't know what drivers y'all seen it pop up 100 times when you put it like a new USB stick in there. It'll pop up saying installing driver. What's the driver? Not a program. Not an application. A device. So everything in the computer, everything that's run by the computer requires a program to run. Everything. So this computer doesn't know anything. All it knows how to do one thing, it knows how to run programs. That's all it knows how to do. So it means if I've got a hard drive in here, then it's got to have a program that gives us access to the hard drive. These programs that are written to control specific hardware devices, these are called drivers. And that's what an operating system is. It's normally just thousands of drivers. And then it's got one program that allows you to control it, and we refer to this as the shell. So Windows uses a shell called Explorer. And what does that Explorer give me the ability to do? Well, it gives me the ability to launch files, it gives me the ability to create files, it gives me a lot of different abilities to take control of the computer, and it decides what drivers you use. And that's an application. An application is a program, an application has no drivers in it. It applies the operating system. The drivers are already in the operating system to run that program. So that's what we do. So when I load up RS Logic, that's an application. And y'all familiar, we call the store we go to get that, we call it the what store? We call it the App Store, right? There's no drivers in those applications. Everything is already in your phone. And all that guy does is just use the drivers that's there. So RS Links this is where we would go, and it says right at the top says what? Can y'all see this? Configure drivers. And so we've got to make sure that we have the driver on hand that has the ability to connect to that PLC. And here's all the drivers that are supported by RS Logic 500.
Now, do you automatically install the driver?
Sometimes it does, sometimes it don't. Here it don't, because it has no idea what PLC you got. Okay, I understand. USB is unique. USB is unique in that USB is Universal Serial Bus, by the way. What it does is that when you plug it in the report, it comes up and tells your operating system, I need a driver, and the operating system says, give it to me. So what's nice about a USB stick is that a USB device is that the drivers are on there. Originally, it was extremely hard until they came out with Windows XP, which is what we call a plug-and-play operating system, P&P. Used to, we had to flip up boards and switches and all kind of stuff on these devices, but now it's a lot simpler. This is also true on RS Logic 5000 also. So we're using two interfaces here. We're using the data highway, also called the DH485, and then we're also using Ethernet. So I'm running this guy right here. So it says it's there, so we're okay, right? And then now we can go up and we can open up our application, wherever it is. And how many PLCs can we connect to this one application at a time? A lot. Yeah, I don't know exactly how many. So when you go to communicate on this, you'd go to comms and you'd go to system comms, and then you would select which PLC you want to be programming. So we're going to program this guy right here. And I'm going to say, okay, now we're ready to start programming this. And this is true even on the Siemens software, because you can have multiple PLCs networked together. And when you want to work with one of them, what do you have to do? Well, you plug your computer into the network, and then you select which computer you want to program or modify or monitor and that kind of stuff. Okay, so now we're ready. What's the next thing I need to do? Yeah, well, okay. How do I get that to pop up? First thing, so we got to create a new one. Yeah, new. Then we select the. And then where do we find this information at? On the side of on the processor. Except on these guys, it's going to be on the door of the CPU. This is a MicroLogic 1100B. And now we're ready to go. Okay. And then, of course, some of y'all had problems with your commands. So what does this guy do? What does that do for us?
Add a new rung.
Add a new rung. What does this do? One branch or a drop down, right? So we can make parallel circuits. This is a what? It's a no, you can't see it, don't have a slash to it. It's hard to see. It's an exam. This is the instruction is a what? Examine is closed. Good. Sorry. This is a what? It's exactly what. Examine if open. This is a output energized. And then this is a latching output energized. This is the unlatching, right? Everybody okay? And we looked at those.
What is it?
This is latching. I know it's hard to see, guys.
Yeah.
A latching output energized, and this is an unlatching output. And we showed y'all, we demonstrated that in class, right? So I'm going to come up here and I'll highlight this, insert a new rung, right? Of course, it starts off with an arrow. And then we'll bring an input, we'll bring an examine if closed instruction in. And then we put a down drop, and then what do we have to do? We take these instructions, come down here on the lower end, and then slide it into the, okay? Now, a lot of y'all, for your output, so when we have on a motor control, when we have a light is not driven by an input. A light is driven by an output, right? You understand that? So when we come up here and define these, we're actually defining which input port we're using on our PLC, right? Or we're defining a contact that's being controlled by something, by okay. And what do I need to do? You can do it on the fly, or you can build your circuit and then come back and do it later. But what do I need to do now? Have to assign the addresses, right? And how's it go? I for input, right? Then we put a module number, and then we put a slash, and then we put a bit number, right? And then when we enter it, we hit enter. This is where we're going to come in and get give the symbol a name, right? And if we want to put comments, we can type comments up there. Some of y'all were getting confused between these two. Yeah. And Mr. Olson he got all these nice comments up there.
Yeah.
He wondered why his arrows wouldn't clear up. This, we can assign that to an input, or we can assign it to a output enable that controls that contact. Oops. And we had somebody we had somebody on I don't remember if it was on this class or not. No, it wasn't. When they entered the time into the time the class starts in the syllabus quiz, they used O's instead of zeros. And that's one thing that you'll find somebody in this class is going to do that, because the O and the zero key are right on top of each other. This is one reason why Siemens decided not to use the O for output. They use Q for output. So now the keys are not right on top. Somebody in this class is going to use what? They're going to use a 0 as an O, or they're going to use a what? O as a 0. Well, they did. They used to do it on computers when they originally came out. That was a technique that we used. Programmers always used, because when you're writing a program, there's a lot of difference between an O and a 0, so we'd slash the 0. Originally, when they came out with the codes, they put a dot in the center of a 0. Now they just give them a different shape. So an O is what? Is round, and a 0 is oval shape. Better bet somebody in this class is going to do it. They're going to wonder why they're going to wonder why they can't clear their error, and they're going to look at it and look at it. Everything's going to look correct. And then they're going to come over here and they're going to say, I can't figure out what's wrong. And then, okay. So now this is not an input. It's still called an examinative close, but now this contact is controlled by this output. Is there anything wrong with this? I'm going to check it. Looks okay. Is there anything wrong with it? So we'll download it to our PLC. Oops, check it. Checked okay, right?
Something wrong with it.
Yeah, there's something wrong with it. Bad wrong with it. I'm going to download it. We did the check, right, and it disappeared. So all that's telling us, guys, is that the syntax is correct. It don't mean the circuit is correct. It means the syntax is correct. So if you use O's instead of zeros, or vice versa, you'll never be able to clear that error. And it would pop up down there saying that you got an invalid address. And so on that run. I'm just going to put them on my desktop. We go through this because we got our these guys don't have that switch on it where you switch it between remote and okay. So we got it in monitor. I'm gonna come over here and switch this. I'm gonna hit switch 0, energize it. My motor's up and running. What's the problem? This motor's out there running. We didn't put what? We didn't put some way in there to stop the motor once we started. That wouldn't be good in the industry, would it? So we'd say, okay, I messed up. So what we need to do, go offline, right? Then we come in and add a input. Oh, got to highlight it first. So I forgot to give it a tag. I forgot to give it a symbol. Come back, pick it again. Looks okay. Then I'm gonna come down here and we'll download it. This is where you can assign it a version, a note, and it gives you every time you modify a program, you can save it under a slightly different number or name. So let's look okay. Okay. So what we're going to do now is we're going to wire this up. So first thing what we would do is we would set up our PLC, and this PLC right here. Figure out what to do about that. I got to keep going. So what we want to do is we want to set our inputs up for syncing, and we want to set our outputs up. Our input port for syncing, we're going to use sourcing devices. So that means we're setting our input up for syncing. And then we're going to use syncing devices on our output. So we're going to set it up. We're going to set the output of the PLC up for sourcing. Now this PLC is really easy to see. If I can get it close enough. It's hard to see, guys, but here's a common right here. So this is a common here. And what's nice about this guy is we can set the inputs up the way we want. What I've done is here's my power supply coming up from the box here. The black lead, what do you think the black lead is? Yeah. What do you think the black lead is? It's a DC power supply. What do you think the black lead is? The negative. Okay. Now understand that. So syncing is we can set this guy up. So you can't say it's common because common is anything you want to make common, right? You understand? So if I was going to set up, if I wanted to set up the inputs for sourcing, then the plus would be the common. If I wanted to set up the inputs for, and I know y'all probably knew what y'all was saying, but in this guy, y'all got to get it right? You understand that? So here's the black lead. It's not a common, it's the negative of DC supply. Then I have this coming from here, and I have it, you can't see it on this one, and I'm picking up the common where? Can y'all see that? Over here. This is also a common too. I don't know if y'all can see that or not. This comes from another source. Then when I come over here and look at my outputs, and this is going to be angled, guys, I'm sorry. Now this guy's got all kind of commons on it because this is a relay output, which is pretty neat. Me and my camera. So notice what it's got. It's got DC, 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 and it's also got AC on the top. This is real hard to deal with. There we go. So this guy, what's nice about relay outputs is you decide what common you want. So notice I can use two commons here. I can use what? You'll see what that says? Anybody? Both AC, or I can make it what? Both DC. This is the plus coming in. And notice what I've done to all the commons. I just did what? Jumped them together, right? And then these wires on the bottom, these are actually what's going out to these outputs down at the bottom. Okay? Are we okay so far? So these are the boxes. These are some of the boxes that I made up. Here's the power supply. And over in Germany, they use blue for common, and they use red for plus, not common. They use, I did the same thing. They use the blue for what? Minus, and then the red is for plus. Okay, makes sense? Okay. So I want to wire up my inputs. So here's my inputs. It's on this box right here. And so I've got a bunch of inputs. I've got a normally closed push button right here. And then this is a normally open, a normally open, a normally open. This is a normally open. This is a inductive sensor. This is for analog, and then we've got some switches over here that we can use. This is a motor that's running an encoder, which we won't get to. An encoder is a device. You can see when the motor spins, it spins these little holes. This is we call it a through the beam sensor. So it shoots a light beam across, and every time this thing turns, when the hole goes through, it lets the light go through and it blocks it. We can use that to sense speed. So right now all we're going to do is use these guys over here. So I want to hook these things up for sourcing. And all I've got over here is the same size conductor. So what do I need to do? Yeah, so what I'm going to do is I'm going to hook this up. I'm going to take a wire and hook it up to the positive, right? Y'all understand? And then these are switches, so it don't make any difference. But just to keep it straight, we'll put the black. So I'm going to hook it up to that switch right there. Then what would I have to do? It's the common for all the inputs. So what would I have to do now? I just come up here and I would just start jumping all these guys, right? I come up here and put that there. And then I would jump it into this guy right here, right? And I would do what? So everything that I hook up here, it's going to run a positive common. I'm not going to hook. I didn't need to hook up all these because we're only using push buttons, but I just wanted to make y'all understand how this would go, right? Okay. Now we're using 2 push buttons. So we're going to use, right now we're using the normally closed push button. So what would I do now? I would take this wire right here, and then I would hook it up to input 0 on my PLC. Now, this is why we do this, because what it does is bring the inputs of the PLC down to these guys, and then I can control the switches. So that's my normally, where did it go? Oh, I missed my column. So I got my normally closed hooked up to input, with my normally closed on input 0. I think it was on input 1. And then I'll take a normally open and hook it up to input 0. And these wires, all they would do, instead of running to this jumper, they would run up to those ports, screw them down on the PLC. Okay, is everybody okay? Yes or no? Whoa. Now what would we do with our outputs? So since we got sourcing outputs, what would we do with our outputs? We'll make it syncing. So what am I going to do on this box? So here's my output box. Instead of running the motor, let's just turn on a light. So what would I do on this guy? Well, what I'll do now is I'll take the minus on these guys, because the output for sourcing. I'm going to take the minus out, which would be the blue, and then I'll run it into the common of one of the lights. But if all these were outputs, what would I do? I would jump all of them, right? You understand that? And then I'm going to take this and run this to output. We used output 0, right? And I'll run it up to this light. Not in this class. Next class, well, but here what you're going to do saying, do we have a lab we do this? No, you don't actually do it. In this class, what you do is you draw the connection. So y'all have already run into that, right? And so I'm just showing you physically how we do what. It would actually be wired up. The only class where y'all actually truly wire the PLC, except for drawing it out, would be in PLC 3 if y'all took that class. Wiring, yeah, wiring, how you wire the things, it's on every lab. Every lab you're going to do, it's going to ask you how to drive it. Huh? Yeah, but it's going to be like it is in your lab book. So you're not going to wire it up. You're just going to draw how you would wire it up, right? So let's see if we do this. So we should be able to do what now? What's wrong? Well, that doesn't make any difference. Right now we use the normally open push button. And that's important. So right now, this guy right here should be, this guy, I don't know, okay. So, it was working. So what I'm doing is normally, what we would have to do, guys, is right now it's showing this guy. So this is this input right there. What's the problem? So normally what should a stop button be? Let's rewire it. I'm gonna move this. Okay, so I'm gonna move it over here. Okay, yeah, so what I've done is I moved this over to this push button right here. And this is my stop button. Everybody okay? And so I come over here and press this button, seals in, and then our light comes on. Some of y'all can see it back there, some of you okay. So here's my light. Okay. And then I come over and hit this button. I'm sorry, this button, I moved it over, and the light goes off. Yeah, what happened is that normally we say the problem we have with people learning this as a normally closed contact is that it's not a normally closed contact, it's an examine if open instruction. But what we want this guy to be true when we come up here and start this. So let's show what happens. I'm gonna come over here and let's move it over to one of our motors. Oh, I need the motor. Right. Oh no, I'll put it right. This way y'all can actually hear what's going on. Well, there's a motor out there running. A little piece of tape. I'm gonna come over here and pull the wire, so that now everything appears to be working okay. Right? I'm gonna come over here and pull the wire out of my supposedly stop button. Yeah. So the problem we have in motor controls is when we need a stop button needs to be normally closed, right? You understand that? So what we're doing, we're using a what? This is an examine if open instruction. So if the wire comes out, I just created an open and my stop button not working anymore. So this is not good. So we go offline. And what do we need? We'll go offline. Change this to what? Yeah, examine if closed, right? And then I'm going to move it back over to a normally closed speed button. We'll make sure it compiles okay. And then we'll download it. So now it's a normally open, but it shows it's true because it's a normally closed contact, and we're using the examine if closed instruction, right? So now we can start it. We can stop it. We can start it. If the wire opens on the stop button, and what does it do? Yeah. That's the safety feature. And unfortunately, even this textbook, the guy's going to be, the textbook, the guy's going to draw this same circuit, and he uses an examine if open. He uses an examine if closed instruction. No, I'm sorry, he uses an examine if open instruction.
Stop it.
Huh?
The stop it is examine if closed.
No, this is an examine if closed instruction.
Yeah, that's what I'm talking about. The stop it.
Should be. Now you have to understand it's the application, and I didn't say always. I said what? Normally.
When you push it, it stops the circuit because it makes it. If you start.
No, well, technically, we're not looking at opens and closes. What we're looking at is ones and zeros in a data file. So an examine if closed, if there's a 1 in that data file, it says it's true, right? If it's an examine if open, if there's a 1 in the data file, it says it's false. And that's the big difference right there. So these are not actually push buttons. These are instructions in a program, right? Understand? And all we get from the push button is we get a 1 or we get a 0. And then it's up to you to decide what you want to do with that 1 and what you want to do with that 1 and that 0, right? We got 2 instructions. We got this guy, which we call a what? Examine if closed. That only deals with an input device, right? So this guy right here has no data bit. So when this guy goes to a 1, this guy is there. And it's not examining a data file, right? You understand that? So that's something else you got to understand. So this is an examine if closed. This is a normally open contact. So this examine if open and examine if closed only refers to if I put a what right there? Input. This guy, if this energizes, this goes true. If this de-energizes, this goes false. So this is not examined inside the data file. These are examined inside the data file, right? So I know that's kind of confusing, but I don't know how else to explain it. So that examine if open and examine if closed only comes into play if it starts with an I. These are basically just contacts that are controlled by other devices. So this is totally software. There's no such thing as this contact right here. No, there's nothing wired electrically to this. So what controls this contact right here? Yeah, that output.
You know, it always seems to me like there was a line going through that. It's like magic. I'm not making.
Well, they're not changing the instruction. All they're doing is showing you when it's true. So if it's green, it means it's what? if it's highlighted in green, it means it's true, right? If it's not highlighted with green, it means it's false. But normally over here we say these guys are energized or de-energized when technically they're not. So okay. So showed y'all basically how we would wire these things up. They're not that complicated once you get the string of things right. In this class, what are you going to do? You're going to draw them, right? According to your PLC, not according to the lab, according to your PLC. So on all the diagrams in the lab, it's got a 120 volt DC outputs, and none of our trainers have that, right? So if y'all, some group gets really ahead, we might let y'all wire up one of your labs. We did that in one class because we had one group that flew through these things like they could have taught the class. What's chapter 7?
Going out after 6.
Exactly right.